Hi class. Today is one of our first videos that we're ever doing. You'll probably see more of these in the future, but I thought this would be a great idea to get us started, especially in case the snow starts rolling in over the next couple of days. So to get our new unit started, which is water resources, the first thing I wanted to do is just take a look at the amount of water that we actually have available on Earth. Now, it looks as though you see this one little ball of water over here. That represents 70% of the Earth's surface of water. Now, I know that you're like, okay, well, 70% of the Earth is covered in water, but remember, it doesn't go that deep compared to how thick the actual Earth is. So if you were to take all that water and compile it into one area, it would take up about this amount of space. Now I know that's is still a very large amount of water, but just to kind of give you an overall visualization of this. But out of this 70%, only 2.78% is fresh water. And out of that, if you see this tiny little dot here, this one right here, it's very small, 0.47% of that fresh water is in lakes, rivers, and streams. Okay, so to get this started, I just wanted to show you this one now. If you see 97.22% of all the water, that's 70% water on Earth, is actually salt water from the ocean. So it doesn't leave much. Only 2.7% is fresh water. So 77.28% of the fresh water is in the form of ice and glaciers. Now, if this ever started to melt, that would actually go into the salt, and then we would have salt water, and then a lot of these freshwater reserves would be gone. 22.22% is below ground in the form of groundwater. You probably have also heard of aquifers, and we'll talk about those a little bit later. 0.47% is on the surface of fresh water, like we had said before, the lakes and rivers and streams. And then, of course, we get 0.03% is atmospheric water, the condensation and things of that nature that form into the clouds. Okay, so a little bit more about these aquifers here. I'd like to talk about those. If we look at this diagram on this next page, there are sources of usable groundwater. Okay, so in between these rock layers, these permeable rock layers, we get some water that gets stuck into these areas. And what we can do is we can use, maybe some of you even live on land where you have a well. You can use a pumped well or something of that nature to get the water out of the system. Okay, so because water can easily flow in and out of these aquifers, this area right here, we call these unconfined aquifers. Okay, that is because they are, if you see, well, I think I have another picture coming up here, but there's these permeable and these impermeable layers. If you have unconfined aquifers, they can flow in and out of the aquifer easily, okay? But then down here, this is an impermeable layer of rock, okay? So you can get what's known as these confined aquifers down here, and that's because of this impermeable or confining layer that impedes water flow to or from this aquifer. Now, the uppermost level that you're seeing right here, there's this dotted line right here, okay? And this area right in here is what's called the water table. The water table is considered to be the surface of the groundwater in that actual area. In Tennessee, it may take, quite a few feet before you ever get to groundwater. But where I was in Tampa Bay, you really couldn't go that far down. As a matter of fact, many swimming pools could not go below 6 feet because you tap into groundwater pretty easily. It's another reason why probably nobody that I know of has basements in the state of Florida, because you get to this water table pretty easily. Okay, so again, just these aquifers, they show different types here. They're in between these porous rock layers covered by soil, and most of them can easily flow into and out of the area with these unconfined aquifers by these permeable layers right in through here. But this is a impermeable layer, so the water kind of gets trapped in there. Okay. Aquifers are also important sources of fresh water for many organisms. Plant roots can access groundwater in an aquifer and draw down from the water table. And water from some aquifers naturally percolate up to the ground surface as springs. And Florida has many springs, which is, a great source of drinking water. So, and they also just, they have freshwater aquatic biomes. They serve their purposes for those too. So when an aquifer has an opening at the land surface, the water can flow out to form a spring. And springs such as one I'm thinking of, I guess, in New Mexico, can be important sources of water for organisms, just for, just fresh water in general. Okay, so over here, this next one. This is showing you, so we have this water table right in here, okay, and water can come down and percolate down through this area into this groundwater state. Now this here can be impermeable layer right in through here, this 5 and 6. Okay, so, but this is showing a permeable layer that gets down into this area, and it's unconfined water. Okay, so we're going to talk a little bit later on about the Agalaga Aquifer, and it's right in through, it starts in South Dakota, goes all the way through Nebraska, Colorado, Kansas, Oklahoma, down to New Mexico. And it's really cool because it covers, I think, like a surface area of about 450,000 square kilometers. Now, usually this aquifer that we'll discuss later on in class is great because it serves wonderful purposes for many of the farmers in that area for irrigation of their crops. So these aquifers can become very, very important. Okay, this one here is a saltwater intrusion. Normally speaking, okay, let's say you have the water is coming through. Here's sea level, and here's the sea floor down here that has also the salt water. Well, sometimes whenever a deep well is heavily pumped, the recharge of the water table can keep up with the pumping. But in contrast, when a deep well pumps water from aquifer more rapidly than it can be recharged, it can form what's called this cone of depression. Okay, and what that means, well, here, let me make it a little bit more cone like. Okay, so what happens here, the salt water can intrude in. We call this saltwater intrusion, and it does make like this conical shape here. Okay, so, and then of course that reduces greatly the amount of fresh water that is available. So this is just kind of an idea to get us started a little bit. We're going to be, of course, talking more and more about this as the class goes on. Now, don't forget, I did give you that study guide that I'd like you to start reading over for Chapter 13. The next thing that we're going to talk about are levees, dikes, and dams. We'll talk a little bit about what happened with Hurricane Katrina, and we'll also talk about one case study with dams that's happening over in the Oregon area and some Native American tribes that are basically losing access to the salmon in that area. So a lot of cool things coming up on the horizon with this water. And so this is just to kind of get us started a little bit. Keep reading and taking your notes.